For our physics presentation, we will be demonstrating a seesaw or lever and what happens to an object when a different one is dropped on the other end. We will be using a Lego people to represent us. Object A will be Mili, the Lego person in yellow, and I, Rodgert, will be Object B, the Lego person in blue. The seesaw will be constructed simply with an eraser as a fulcrum and a 3cm ruler as a lever. We will drop Object A from a certain height onto one end of the seesaw. This action will cause the other end to rise and throw Object B into the air. Now let's watch it live. Now what we will be trying to discover is the acceleration of Object B when you drop another object, or in this case Object A, with a greater mass from a certain height. How far will Object B need to be from the pivot or center to maintain an equilibrium and not accelerate up? We will do these calculations assuming that there is no air resistance or any loss of energy due to heat, sound, friction, and etc. Now let's do some calculations.
Now the big question is, how far does person A need to be from the pivot to maintain an equilibrium and to not accelerate upwards? To find person A's acceleration, we can use Newton's third law. We have to assume that the distance between the pivot and person A is equal to the distance between the pivot and person B. Therefore, the force exerted back by person A is also the same. F net is equal to mass times acceleration, and F net is equal to 1,715 newtons. Mass of person A is 25 kilograms, so we can find acceleration, which is equal to 68.6 meters per second squared. The amount of force exerted by person B onto the seesaw is 1,750 newtons, while the amount of force exerted by person A is 245 newtons, due to a difference in their masses. Person B's horizontal distance is 1 meters away from the pivot. We can use this relationship to find the answer. So person A needs to be 7 meters away from the pivot to maintain an equilibrium. The two events for this situation are event 1 and event 2. Event 1 being this: person B is at rest above the seesaw. Event 2, person B reaches the end of the trip down right before it hits the seesaw. The mass of person A is 25 kilograms and the mass of person B is 175 kilograms. The height from which person B is dropped is 5 meters above the seesaw. To find the velocity of person B, we will be using this formula. Eg1 equals Ek2. Eg1 can be replaced by mgh and Ek2 can be replaced by mv squared divided by 2. Now we will sub in the values and find v, which is equal to 9.90 meters per second. Since displacement is 15 meters, initial velocity is 0 meters per second, final velocity is 9.90 meters per second, acceleration can be found using one of the big 5 equations, and it turns out to be 9.8 meters per second squared. F net is equal to mass times acceleration. We can use the mass of person B and acceleration to find F net, and it turns out to be 1,715 newtons.